This is video number 5 for sections 11.4 and 11.5, more examples with nonlinear systems. Take a look at this example. It's another system that we're being asked to solve. We'll take that same approach, which is we'll draw graphs first so that we can know how many solutions, and then we'll use substitution to find the solutions. Let's see, this first one, hopefully what pops out at you is it's a circle. It fits that exact circle format. It's another pretty easy one. The center again is at 0, 0, and the radius would be the square root of 36, which would be 6. So if I go to 0, 0, and then if I head out 6 in all 4 directions and connect the dots, I've got myself the circle. And then the second one is just a simple line. It's just y equals mx plus b. Remember, we said one of them might be a line, just not both. It's already in the good format. The y-intercept, you can see clearly, is 6. The slope is a 1, so that would mean go up 1 over 1, or you could say go down 1 over 1. And then connect the dots, and we've got ourselves our line. So clearly this circle and line cross each other twice. Once I can obviously tell where it is. It's this spot right here. The other one, I wasn't being super careful. I'm guessing it might go through this -6 spot. We'll find out when we do the algebra. But all I really care about at the moment is how many solutions. There are clearly 2 solutions. In terms of finding the solutions, we're now going to go ahead and use the method of substitution. This system is just ready to go for substitution because one of the letters is already sitting there by itself. Great. So I just have to take the other equation, this one, the first one, and recopy it. When I get to the letter y, I'll need to fill in x plus 6. So x plus 6 squared equals 36. My next step is just to solve this equation. It again appears to be quadratic, and I'm going to have to FOIL out this piece here. Exponents don't distribute to addition problems. You can go off to the side if you need to. I think what I'm going to get is x squared. I'm going to get a couple of 6x's for the outer and inner, and then a plus 36. It is quadratic. I'm going to get a 0 on one side. I have 2x squared. I have the 12x. And actually the 36's wipe each other out. That's nice because this is very easy to solve using just the factoring method. I have a simple GCF here of 2x that I can pull out. And then 0 product principle. One of these two guys has to be equal to 0. It looks like I end up with 0 and -6. Remember, that's not the end of the problem. Those are just the 2x values for my 2 solutions. In other words, at this point, I know that one of the answers is 0 comma something, and the other answer is -6 comma something. To figure out the something, I have to go back to the substitution equation, which was this equation, and one at a time, I need to plug in each x value. So first I'll plug in x is 0. That's easy enough. It gives me 6. And then I need to plug in -6 for x, and that gives me 0. I can fill in those solutions. Here are the final 2 solutions. I believe they match the picture, 0, 6, and we were suspecting that it was -6 comma 0, and sure enough, that's the solution. We have these 2 solutions for this particular system. Let's take a look at the final example problem here. This one I think is a little bit messier. Same approach. Step 1 is let's get some pictures going here. What am I looking at? Well, I see x squareds and y squareds everywhere, so I know it's one of these new shapes. The coefficients are different everywhere, so circle is out. That leaves ellipse and hyperbola. It's all about the minus and the plus. The minus one is going to be a hyperbola. The one with the plus is going to be an ellipse. Neither of them is in the good format. The top one needs everybody divided by 64. So 64 here, and here, and here, if I can squish that in. That's going to then simplify to x squared over 4 minus y squared over 16 equals 1. It is a hyperbola. It is a horizontal hyperbola. I know that because the x comes first. My a in this hyperbola is 2, and my b is 4, the square roots of those numbers under the x and y. Horizontal hyperbolas have x-intercepts, and we said they always occur at plus or minus a, so that would be plus or minus 2 in this situation. And then we just need to think about the asymptotes. And essentially what we've been saying is that the b number tells you the rise, and the a number tells you the run, the horizontal information. Going to the picture then, we're centered at 0, 0, like all our hyperbolas. And I need to go up and down 4 and side to side 2 in all 4 directions. So up 4, right 2, down 4, right 2, up 4, left 2, down 4, left 2. There's my rectangle that I can draw. And then I can connect the corners to draw my asymptotes. My x-intercepts are at positive 2 and negative 2, and then I just need to draw in the hyperbola in such a way that it looks like it's becoming the asymptotes, or getting really, really close to the asymptotes at the ends. Okay, then we need to look at the ellipse. The ellipse is also not in the good format. It looks like it needs a 16 everywhere. I'll write the equation over here, x squared over 16. The other one, everybody cancels. I'll leave the 1 and then a 1 on the other side. Ellipses are easier if I can just identify the a and the b, the square roots of those two numbers. That tells me the x and y intercepts. This thing is centered at 0, 0. It has x-intercepts of positive 4 and negative 4, and y-intercepts of positive 1 and negative 1. Let's draw in the ellipse. And after all that, I can see that the red hyperbola and the green ellipse intersect 4 times. This particular system has 4 solutions. And this time, I have no idea what they are. Those are not nice spots on these graphs, so I will have to use algebra to find them. We're going to use the method of substitution. I don't want to use the adjusted equations. I think the original equations were much better, so let me recopy those. And now I need to isolate one of the variables. Actually, I'll do that squared trick again. Everybody's squared, so I might as well just isolate either x squared or y squared. There's really only one good choice. This x squared is the only easy one to isolate. I can do that pretty easily by just moving the 16y squared to the other side. And then once I've done that, I take the other equation, I recopy it, but when I get to the x squared, I fill it in with my new name, namely 16 minus 16y squared. And then continue to copy down the rest of the equation. I have minus 4y squared equals 64. You can see there's a lot of similarities in these problems. Once again, I've got a quadratic. I need to go ahead and clean it up, so I'll multiply. 16 times 16 is 256. And then I've got some like terms. Those two terms with the y squareds are like terms. I believe that makes 260. There's only one y showing. It is quadratic, but there's only one y showing, so I can use the square root method just fine. Let me get rid of that 256. 64 minus 256 is negative 192. And then I need to divide both sides by that negative 260. The minus signs canceled out. And then, I suppose I could reduce this fraction, but we already know these answers aren't nice. We're just going to do decimals for this problem. So I would just go right to the square root method, square root, square root. Don't forget the plus or minus. We're going to reach for the calculator now. And if you do that, you get this nice messy decimal. I've kept it long for now. We'll round later, but I'm not done using this, so I don't want to have any rounding errors. One thing worth noting is I've only gotten 2 numbers here for y, but I thought we were supposed to have 4 answers. It might be a good idea to look back up at that picture. Why am I only getting 2 y values if there are 4 answers? Well, hopefully what you notice here is this picture is very, very symmetrical. There are 4 answers, but notice that these 2 top answers appear to be at the same level. In other words, they have the same y value. And these 2 answers also appear to have the same y value. So I think we have found what we need. Let's get back to the algebra. After we find the y values, we're supposed to go back to the substitution equation, which was this one, and we are supposed to fill in the y values one at a time so as to figure out the x values that go with them. Do you see that I can do this all at once? Because whether I plug in the plus or the minus, I'm just going to square it here, and that's going to result in the same answer. So I think I can do it all at the same time. I'm going to have x squared equals 16 minus 16 times either of those 2 guys squared, and as soon as I square it, I'm going to lose the plus or minus. Squaring things makes everybody positive. When I reach for the calculator, here's what I get. I have x squared equals 4.184611. I'm keeping it long again since I'm not quite done with it. And then I just need to square root. Don't forget the plus or minus. My final values of x, I will go ahead and round now, are plus or minus 2.05, rounded to a couple of places. Now, I'm going to have to think about this picture again when I think about how to write my final answer, because I have to give 4 answers here. I only got 2 x values, just like I only got 2 y values. Again, it's the symmetry of the picture that you should notice. These 2 solutions share the same x value, positive. These 2 solutions over here share the same negative x value. Basically, all I have to do is put together every possible combination that I can of these 4 numbers. So one of the solutions, for example, would be positive 2.05, comma, positive 0.86 if I round that y to 2 places. That's one answer. But then I could also have positive 2.05 and negative 0.86. But then I could also have negative 2.05 and positive 0.86. And finally, I could have both coordinates be negative. If you glance back up at the picture, this should make good sense to you. You can see where having the picture is pretty helpful. Without that, I think it would have been hard to realize that all 4 of these were solutions. Remember, when you're doing the homework, you should be drawing graphs first, and then you should be cranking out that algebra, this substitution that we've been demonstrating. That is the end of the lesson and the end of the course.